All right, today we're talking more about our angle pairs and transformations that lead to congruence. With those angle pairs, it says notes for worksheet 2. This is actually for worksheets 2 and 3. And then you'll start worksheet 2 today, but both worksheets 2 and 3 will be due on Monday. Tomorrow will be a work day for you to work on both 2 and 3 in class, since our notes are a little long for this one, and so are the worksheets. So today you'll do your notes, you'll start worksheet 2, tomorrow you'll finish worksheet 2 and do worksheet 3. So using rotations, what do you know about this picture? Okay, so we're talking about this picture over here on the right, and we know that if I rotated point A about point O, or maybe it stands for the origin, 180, that they would be equal. So if I took rotation is a capital R about point O of 180 of point A, I would get A prime, or vice versa. Then it says when two lines intersect, 4 angles are formed. So follow steps and label. Note AE is not equal to EC and BE is not congruent to ED. So we're not saying that these are bisectors where they intersect. We can't know anything about the segments necessarily. But it says complete the following. If I rotate C about point E of 180, I would land on C prime, which is the same as A. And if I rotate point B around E of 180, I would get B prime, which would be the same as point D. So angle BEC prime should be the same as BEC. So we're saying that these two angles would be congruent. And really, this is the start of a proof. We have shown that vertical angles are always congruent through these first 4 steps. So the measure, this is saying therefore, these 3 dots mean therefore. Just shorthand. The measure of angle BEC is congruent to the measure of what we don't want. We want AED. Or actually, let's do it in the correct order. DEA. Since we started with B, we'll start with B prime. DEA. Okay, we will get into proofs more in this unit after today, but really you're just taking the steps to show that something is always true. We're proving something that we know to be true. These are called vertical angles, and we have proven that they are congruent. And we talked about vertical angles yesterday too, but now you know they're always congruent. Parallel lines cut by a transversal. Using our diagram on the right, which line is a transversal? And that would be line M. Okay, they've labeled it M, or you could say line RQ if you named it with the points. But this is the transversal because it's the one cutting through the other 2 lines. What do you think is true about angles 5 and 6? And I would say based on their size, I think that they are congruent, and because they're corresponding on parallel lines. I could also, if I translate H to G, line H to line G, they would match up. Angle 5 and angle 6 match. These are called corresponding angles. And we have proven, pretty informally, but we have proven that they are congruent. All right, next it asks us, what do we think is true about angles 2 and 3? So I'll use a different color here, 2 and 3. So let's think of our transformations, and I'm going to go ahead and put a point in here for the center. And I'll just call it O, or origin if you prefer that, but point O. How could I get 2 to match up with 3? So I think I could do a couple things, and actually I don't need this O, I don't think, because I'll need 2 transformations instead of just 1. But I could, let's see, I could rotate angle 2, this whole line, and line H, rotate about point Q 180 degrees. That would match up 2 with 4. And then I could translate to match 3 and 4. Angle 3 and angle 4. And these are called, just 2 and 3 are called alternate interior angles. Again, we learned about them yesterday. And we have proven that they are congruent. And these proofs we're doing only work if your lines are parallel. So I mentioned that yesterday too. They're always angle pairs, but they're not necessarily congruent unless your two lines that are being intersected are parallel to each other. So you have to be careful. And we're showing that they're parallel by these little arrows. So since they both have 2 little arrows, that means that they're parallel, or they could both have 1 or both have 3. That's just how they're denoting that those two go together and that they're parallel. All right, next page. What do you think is true about 4 and 7? So in a similar fashion, I could rotate line H 180 degrees about point Q and land on 2. So let's say rotate about point Q 180 degrees. And then again, we could translate to match up 2 and 7. Translate along line M, try to be as specific as possible, to match angle 2 and angle 7. So these are called, if I get rid of my middleman here of angle 2, these are called alternate exterior angles because they're on the outside. And we have proven again that they are congruent, but only because these lines are parallel. Okay, last one for this picture at least. Angle 1 and angle 2 are same side interior. I think that they are supplementary, or I know that they're supplementary. And let's talk about why. So that's why I did different arcs, one arc. If they were both one arc, I'd be saying they're congruent, but I don't think that. I think they're supplementary, so I want different amounts of arcs to show that they are different. And if I was really being careful, I would actually make this one even more since I already have 2 angles marked with 1 mark. And so let's talk about what is supplementary. So supplementary means they add to 180, so linear pairs are supplementary. I could pretty easily match angle 1 and angle 8. So I think angle 1 is congruent to angle 8 by translation along line M. I could slide that and match it here. And then angle 2 and 8 are supplementary because they're a linear pair. Which is going to make, if I swap out 1 and 2 here, then I know that 1 and 8 are supplementary by substitution. So I can swap out anything that's congruent or equal in measure by substitution. These are called same side interior. I'm running out of space here, but same side interior. And we have proven that they are supplementary, or they add to 180. These properties only hold when the lines cut by the transversal are parallel, as I've mentioned several times. And then angle sum of a triangle is also 180. That might come in handy as you're working. All right, a few more examples down here. So let's start with our picture here. I like to fill in as much as I can before I even worry about the angles. So they started with 50 degrees right here. I know angle 8 is also 50 because they're vertical angles. Since these two lines are parallel, I can also say that angles 5 and 1 would be 50. So all four of these are 50. If I wanted to find the other four that are missing from line C, I could take 180 minus 50 and get 130. And all of these are going to be 130 that we're missing on our transversal. Now I need to transfer what I know onto this line here, but luckily enough, these are parallel as well, so this is a transversal cutting through another set of parallel lines, which is going to make this piece translate this way. So these are both 130 here, and then 6 and the one across from it are both 50, and that's also going to happen down here. Since these two are parallel, I can translate this along line B to fill in what I don't know. And then I can now fill out my picture. So angle 2 was 130, angle 6 was 50, angle 1 was 50, angle 5 was 50, angle 4 was 130, angle 8 was 50, angle 3 was 130, and angle 7 was 130. Example 3, use the properties of parallel lines to find the missing angle. That just got cut off. Angle. So here I know that this is 125, so 4 must be 125. Now let's go ahead and take it a step further and find x. So these two are both 125. Those are corresponding angles, and they're congruent because the lines are parallel. And then I know that this angle right here has to be 180 minus 25, so that's 55. So x plus 15 equals 55, which will make x 40. All right, on this one, I know angle 1 is 72 degrees, and these two would also be 72 degrees. So 180 minus 72 gives me 108. So if I want to solve for x, I have x minus 8 equals 108. So add 8 to both sides, I would get 116. And then last one here, these are same side interior angles, so we know they add to 180. So let's go ahead and do 7x minus 8 plus 62 equals 180. And solve. So negative 8 plus 62 should give us 54. If I subtract 54 from both sides, I should get 126. And then we have to divide that by 7. So let's see. 18, I believe. And if I wanted this angle as a whole, I could do 180 minus 62, which is 118. So I could have also done 7x minus 8 equals 118 and found 18 that way as well. All right, that's it for your notes today, so go ahead and start worksheet 2.